Helo everyone, helo pawb. Elin Jones dwi, swyddog datblygu Menter Moch Cymru. I'm Menter Moch Cymru Development Officer for North Wales. Thank you for joining us tonight. Diolch am ymuno gyda ni heno. Warm welcome to you all. Croeso cynnes I chi gyd. Warm welcome and we're delighted to have Heidi Hall from Ontario with us for this webinar. Thank you very much, Heidi, for agreeing to host this webinar. Yeah, we're delighted to have you and hear about the Nuffield Scholar that you did too. So thank you very much. Heidi is very eager if you'd like to ask any questions during the webinar. Please use the Q&A function and then I will ask Heidi throughout the webinar if you have any questions that come to mind while we go through the slides. But we'll have a Q&A session at the end too. So if you have any questions, please feel free to use the Q&A function at the bottom of your screen. Therefore, I'll hand over to you, Heidi. Thank you very much.
Thanks, Ellen, and thank you for the invite. I'm happy to present. So we're going to chat a little bit around gut health and how to manage the pig to maximise profitability and hopefully reduce antimicrobial usage and zinc. So my name is Heidi Hall. I work for Ontario, Global Technical Services Manager. I joined them about 5 years ago as the Global Technical Manager for swine. And previous to that, I worked for a company called AB Agri. You may have heard of them as a feed manufacturer, working really in swine nutrition and alternative proteins. Okay, so today, as I say, we're going to look at gut health, the factors affecting it, what it is, and the impact it can have on producer profitability, the bit that sort of you're probably most interested in. And strategies maybe to help ensure we've got a robust piglet at weaning, and that then can help us to remove that therapeutic or medicinal use of zinc and reduce the need for antibiotics. Okay, so what is gut health? Well, there's a nice definition from a German human doctor, Dr. Stefan Bischoff. So it's effective digestion and absorption of feeds, coupled with an absence of gastrointestinal tract illnesses or diseases. We also can look at that as dysbiosis, a disruption in the gut. And why is it so important? Why are we here? Well, if we look at the negatives of having poor gut health, we've potentially got an increased immune challenge. 70% of the pig and human immune cells actually reside in that gut. So any inflammation is going to cost us energy. And as we know, energy is really pricey at the minute with feed costs. And so we're going to see a poorer FCR, higher cost of production, and longer to reach that target weight. So, you know, compounds those problems. So what can we do about it? And really here we're looking at subclinical. If it was clinical, like post-weaning diarrhea, or ileitis later in life, we'd be probably doing something about it anyway with a vet or a medicinal interaction. But a subclinical problem in gut health is probably below the radar. We're not necessarily seeing it easily. It just could be an FCR lower than what we might expect, or higher rather. A feed efficiency that's worse than where we want to be. And so health status with that massive amount of the immune cells residing in the gut, it has a massive impact on the animal's health. And so health status of the gut is key really to performance. So I'm going to touch a little bit on what I did in my Nuffield project. I went around various different researchers, nutritionists, geneticists in different countries. And there's a link to it at the end if you wanted to read more. But essentially I was asking them whether they were, in their minds, is less more. And what do we mean by that? Well, if you look at the industry and you think about how we deal with gut health, we generally tell people or pigs to use a probiotic or a prebiotic. And what are these doing? So a probiotic is seeding the gut with live bacteria. And this is picking up on key bacteria that we feel we've researched enough and that every pig would need. And so I'm sort of symbolizing this here quite simply, but really we're focusing on a few major species. This could be bifidobacteria or lactobacillus, if you think of Iechyd. Oh, there's another train of thought that really we should be going for diversity. So we've got a maximum number of different bacteria So the microbiome is diverse. And this we look at within gut health as having lots of different types of bacteria. So they might be doing various different things. Some of the things they're doing actually could be, in fact, detrimental. It could be using energy in a way we don't want. And that's why the train of thoughts differ. So one is, well, let's save energy, we save the diet, nutrients, and we keep the key bacteria we need. We don't need the rest. Or you want to go for diversity. And so I was asking them this question, and really I can highlight it in a relatively simple way for us here. If we go through a period of disruption, such as diet change or in fact weaning, if we think of a couple of key bacteria digesting milk protein, for instance, if we cut that out of the diet, they have nothing to eat and then they die. And if we go through another disruption that could be heat stress, and some of them are less able to deal with that heat stress, and then they die. If we look then at what we've got left, in the key bacteria instance, we've got very few bacteria that could be good. And what you generally see, if you think of using weed killer on your land, you then get the quickest ones to come back is generally weeds. And it's the same in the gut. If you clear a massive space within the gut, the first ones that come back are generally the pathogens, because that's how they've evolved. They make use of disruption. So the Clostridia that are within the gut, we need them. They're one of the first bacteria that seed the gut when an animal's born, and they're sort of classified as being helpful in smaller numbers in the right places. But if we wipe out large areas through disruption or potentially even medication use, they can then take over. And if you've ever then seen Clostridium overload, you know, the black gut, you know what I mean. So in my eyes, diversity then potentially is the best way forward, because it gives us a more robust animal that can deal with disruption. And as we know, animals go through disruption every day. That's either a diet change, heat stress, it could be mycotoxins, anything like that. It will have an effect on gut health. And so having that diversity gives us some stability. So if we were looking to establish diverse gut, what do we do, or when does it come about? Well, we know that weaning is a massive disruption. So in a sense of a piglet, we're probably looking at having this nicely stable gut, probably 4 to 5 weeks post-weaning. And if we look at enzymes like xylanase, for instance, when we use xylanase, we only see value payback at this sort of time point. And I'll get to that in a minute as to why. But generally, it takes about 2 to 3 weeks to change the gut microbiome. For good, generally more than bad. For bad, it generally happens a lot quicker, unfortunately. But prior to weaning, a piglet has very little stimuli. If it's an indoor intensive production, it's only really got the sow, the pen, and the milk. It might have had a bit of creep feed, in which case we start to see this diversity happening a bit earlier. But weaning generally signifies this stressful period, but many new stimuli and interactions happen thereafter. New pen mates, new pen, and the like, a new feed, and very many different feeds. As you can imagine, we change that diet very quickly thereafter. So if we then try and pull diversity earlier, because we know that this upper sort of level is a stable, robust gut that can deal with these disruptions, we can generally see it come a bit earlier, and that's where the xylanases of the world come in. So if you've got something that's helping fiber be digested into the small components that bacteria can then make use of, or you're feeding a prebiotic, or you're potentially using an acid, some of this can happen a bit earlier. We can help manage that gut through weaning and create this the robustness that we see later in life. And so really what we're hoping to see is an established balanced microbiota as early as we can. So reducing that disruption around weaning, and therefore reducing the risk of upset and damage on the microbiome and the gut structure. And really this talk's not going into the gut structure at all, but obviously it's key. Tight junctions, essentially the barrier, the wall that separates us from the bacteria. And we do need that in place. So factors affecting gut health. the rest of my field was really looking at how we can understand these factors and what we might need to do about them. And generally, different people, different walks of life, different industries have different thoughts on what the biggest impact on gut health is. So I spoke to geneticists, and in a sense, you may also have seen this in your own herds. You've got different genetics between generally a sire line that looks either at snacking and then going for a nap and wanting to eat at various times in the day, versus meal-eating pigs, which is generally ones that want to eat all at the same time and then they go to sleep. And if they can't all eat at the same time, so we might have a feeder space restriction, we generally see stress. We can potentially then maybe see tail biting and the like. And really that stress response is part intertwined with genetics. And we also see that when we moved out of a stall situation, for instance, into loose housing for sows. And the United States are going through this change now. A number of different sow breeds, so more like the large white, the landrace, or large white rather, the PIC breed is less happy to deal with that. They are more aggressive, which makes them great mothers, but potentially not great for a loose house system. Whereas the Danish breeds, the landrace and the new ones, is more able to deal with that group housing, less stressful, and therefore piglets having a better life early on. But genetics also comes into it in a different way. If we look at a closed house system where we've not taken any genetics in for a number of years, and then you start to see if they have a resident viral challenge, for instance, those sows that have done well and have been selected for are generally resilient or more resilient to that viral challenge. And genetics companies are picking up on this as well. And they're thinking about making them resilient to PRRS, especially in America. But historically, there's also been genetics that are more resilient to E. coli challenges. And so is that something that geneticists are now looking at with regards to removing zinc? We know it's the F4 E. coli, so it's one with a specific fimbrial or an outside structure that's really difficult to overcome at weaning. And like we've seen with genetics within E. coli strains of old, they might therefore be selecting for piglets that are not, or selecting for pigs that then go into breeding that are not as susceptible to those strains. So genetics plays a huge role in gut health and management of that community. Immunity is another one, and so obviously we've got vaccinations, but also ensuring that the sows that are in the herd are the best selected for, and that might be something that we're breeding in there ourselves, so we're buying in gilts or in fact breeding within a closed herd. And so vaccinations and ensuring that immunity pass over to the piglet is as good as we can is really important. Now, nutrition obviously close to my heart, starting out life as a nutritionist, and this is a bit more of a direct effect. You've got diet digestibility and suitability, so age of piglet for the specific diet, and therefore that it looks at milk content and crude protein, but also antigens. You know, countries like the Netherlands and Denmark, they don't feed straight soya to a piglet. They only feed a processed soya, something that's had those antigens removed. So not like the high-pro we feed here. And inflammation, as we've said, gut inflammation really having a negative effect on gut health and then animal health. If we see inflammation, we generally see tight junctions become looser, and pathogens like salmonella can come straight across that barrier. Maternal transfer is relatively new, but essentially it's everything that sow is handing over to those piglets. So that'll be through gut health, because she's handing over, we've got fecal transfer going on. Piglets eat a lot of feces in the first 2 weeks, 3 weeks of life. It's their main uptake of bacteria. So if we can manage the gut health of the sow, we know we can improve the piglet gut health. And there's a paper at the end that will go into this a little bit more. Antibodies, so her immunity has a direct effect through the milk. And obviously the IgA helping gut health and defense in the gut really early on. And also skin, you know, obviously they're taking up milk from suckling at an udder and therefore a teat, and therefore they've got skin contact, the skin bacteria that's also important. and the birth canal. So all of these things start to seed that gut really early on. And the biggest single factor here is probably management of having all of these things intertwined. But the one thing we don't talk about as having a massive impact on the gut, and we really don't measure it in any gut health trial, is stress. And everything leads back to stress, either reducing it or increasing it. And stress has a massive impact on the gut. And the reason for that, or the mode of action of that, is relatively new. And you may have seen this, or you may not have done as yet, but essentially the gut is a second brain. So we've got this gut-brain axis, and now it's sort of discussed more as a gut-brain microbiota axis. So it's this link between what's residing in the gut and the effect that then has on the brain, and then the backwards effect that then has on the gut. And so in simple terms, some of the bacteria we have release nutrients or chemical signaling that is then seen by the animal, and then, or the human, they're received in the gut itself, and then it changes things. The easiest thing I can talk about in this sense is butyric acid. Butyrate is produced by bacteria in the gut because of a dietary nutrient, a fiber source, for instance. And that then has a major effect on the whole diet digestibility because it slows down the rate of passage. That's quite a simple one. And a more challenging one maybe to talk about is that certain bacteria change the way we think. It is really interesting in the sense that they have impacts on dopamine in the brain, and so how well we feel, well-being. And I talk about us and pigs quite related or quite close together because pigs are used as a model organism for humans. So a lot of the work that's going on at the minute in this gut-brain axis is actually using pigs. You know, mice models only go so far. Piglets are used, or neonates are used as model organisms for babies. And likewise, pigs are used for model organisms for humans. So it's a really interesting new field. But essentially for us, as being farming, and we're involved in breeding these animals and producing these animals for food, is we want them to be as healthy as we can, so they cost us least amount to produce. And some of that is simply in the stress response, having an effect on the microbiota, which then has an effect on how well they digest that food, even ignoring that inflammation and energy cost. Okay, so there's lots we could discuss there, but we're going to get on to some of the things we can change in our day-to-day lives. So how do we produce a robust piglet weaning? If we're talking about that diverse gut microbiome, how do we get there? Well, most of this, in my mind, and from my travels and discussions with people, is around the maternal sort of unit, the dam, the mother of those piglets. If we can ensure she has optimum gut health and therefore sow health, that immunity, we're giving those piglets the best start to life. And she's actually more cost effective to input. She has, 2-3 litters a year, 14, 16 piglets each litter, if we can. We're weaning obviously a greater number of piglets. If we input our costs into each individual piglet at weaning, we've pretty much let the boat leave the harbour. You're trying to sort of change something that's already started off, and therefore you've got to potentially remove some of those bad bacteria to then start the good ones coming in. So those factors affecting gut health is really where I would apply it to the sow. So ensuring her diet is good at both stages, dry sow and lactation. And we're quite good in this country with lactation diets as well. We don't rely on laxatives, which some other countries do. We utilise fibre in the sow diet, which is really important. Essentially, fibre is almost a free prebiotic. So lots of different fibres, but largely digested by the gut bacteria. We need the gut bacteria to digest fibre. And that relationship in sow diets is quite interesting. Other countries don't do it so well, so it's good that we live in the UK. Environment, as we said, reduce stress. reduced inflammation in the gut then. Genetics, as I said, if you've got a closed herd or you're buying in your sows, understanding how they'll deal with their environment that you're going to put them in, and immunity. And I know vaccinations are expensive, but the payoff long term is probably enough, not just for that sow, but every piglet she then has. And we want to ensure that weaning transition is a smooth one. We don't want to disrupt them unnecessarily. We have to wean them, but weaning age is important, and that'll come up in a slide or two time. And if we're looking to remove medication or zinc, antimicrobials, the best method I've seen is a stepwise approach. I went to visit a couple of producers that are no antibiotic ever or antibiotic free, and largely they have a method of doing this within the management side. So they're looking at all those factors and they're honing in on how to do that on their unit. And it's not just going cold turkey. It's essentially removing it bit by bit within the maternal or parental herd, and then seeing it being removed in the piglets. So they start with the sow. Okay, so how do we optimize gut health, and how do we then remove those antibiotics, antimicrobials? Well, with piglets, as we've briefly touched on, weaning is potentially too late as an intervention. So piglet's immune function is developed over time with influence from that sow. That's the passive immunity bit. So they've not done anything about it. It's the sow. It's those antibodies from the milk and the environment. And that's the bit that they've had to ramp up their own immune system. That's cost them energy. So active immunity is great and it's needed. We need to stimulate that gut. And that generally comes from diet, interaction and environment, snuffling around. Outdoor piglets have a great start. It's far more challenging, but by the time they're sort of 2-3 weeks post-weaning, they've picked up so much more bacteria from the soil. So weaning is this sort of gap in between, and that's where we can try and ensure we've got the least number of pathogens available from both the sow gut and the environment, so that those piglets are less challenged in an unnecessary manner. And in order to close that gap, we've got to try and ensure the piglet's natural immune system is as good as we can get it. And that's all pretty much coming from the sows. Those vaccination programs, that gut health, the diet, and the environment. Okay, so managing with antimicrobials. For me, I could have had a piglet analogy here, but essentially it's a bit like a chicken and egg. And that'll come up in the next slide. But generally, if we've got a high use of antibiotics, we generally see more use needed of antibiotics. So which came first? And the next slide's where I sort of said to Ellen, stop me if there's any questions, because we're getting a little bit more detailed in the microbiology. We're just looking here at the pie charts. The good guys are blue and green. The bad guys, the salmonellas, the guys that digest protein, that steal it away from the piglet essentially, are in red. And so if we see here, we've got the control. This is a mouse model, but we've got the control having very few red and a great number of the good guys. If we treat them with an antibiotic, we can see we've got a huge number of the red guys. They're the first to come back, and potentially they're the ones we didn't want. They're the salmonellas and the such like that. And even after they've recovered 2 weeks afterwards on normal feed again, we've still got 6 times more of that unwanted bacterial group. And the proteobacteria, the proteolytic bacteria, they digest protein. This is a link with a weaning diet that potentially is too high in protein. So if we go through a disruption at weaning, as we know we do, and the piglets then don't eat as much as they might have wanted to, or they go through a period of starvation, those proteolytic bacteria can bloom. And actually, if we've got a weaning diet that's really high in crude protein, they've got lots to eat as well, because the piglet potentially can't make full use of it, or it's not as digestible to a piglet. It's too high in high protein soya. And so for me, in helping to reduce the need early on in life of antibiotics could help us to reduce antibiotic use, and then we get a better gut health later on in life. And this may not work. There's a little hidden slide here, if it'll click. I'll come to it at the end. But essentially it's about AMR, antimicrobial resistance, and it's not the focus of this talk, so we don't have to spend a lot of time on it. But essentially antimicrobial resistance isn't created new each time we use an antibiotic, but what we do is we start to select for bacteria that can deal with that scenario or high zinc, and it will not be lost within a system. So if the mother carried antimicrobial resistance, she can pass it over to the piglet. Only from killing the animal can we then get rid of it from that animal, but we could in fact pass it on through fecal transfer or uncooked meats to other animals. And that's really where AMR is a little bit of a challenge to deal with, because once it's started within a system, it's hard to get rid of it. And so by no means the pigs are the biggest problem, but there certainly is a higher number of risk factors in pigs than there is in poultry. And I've got a slide to show on that if we're interested at the end, if we've got time. So zinc use, antimicrobial usage of zinc. So we know we need zinc. It's really good to help reduce inflammatory response and improve the barrier function of the gut. It's much needed in cellular repair, and we know we need it in high levels for that because it's in soda cream. If you ever look at the ingredients of soda cream, it's really high in zinc. It's really high in SPF, in sunscreen. It's a really great barrier. So we want to keep it in the diet, obviously, as well for nutritional uses, but it's also not great for good bacteria. So lactobacilli, we know we really like. They digest and produce lots of good nutrients. They produce lactic acid, which helps the gut stay in an acidic environment. That's what we want. Helps keep the bad guys out. And in the end, it leads to increased production of butyric acid, which we know we've already heard of, has some good points as well. But zinc has a couple of negatives. So if given a choice, those piglets don't like to eat it. It tastes like metal. It smells metallic. So that's probably one of the major reasons. It also has little to no effect on salmonella. And so in a sense, we might start to see, or we have been seeing, increased levels of salmonella in pig herds, because it's not being managed by the products we're using. And also it has been linked to antibiotic resistance. So the ban came in 2017. We had 5 years to pull it out of diets. We've now, because we live in UK, not Europe, we've got another 2 years. So the shelf life of the products that we may have purchased, we can use them until they run out of shelf life. But really the major point that wasn't hugely published was that it is linked with MRSA, which we know can be a problem in pigs. It's held in the nasal cavities. And essentially we can see that when we use high levels of zinc, we see a greater level of antimicrobial resistance from that MRSA in pigs. So not just obviously environmental contamination is one thing, but the AMR link is probably the biggest. So in my role with Ampario, we have been looking at zinc replacement. It wasn't necessarily a major focus of my Nuffield because many countries in Europe have actually already pulled it out. We're pretty slow on the uptake on that one. Netherlands had it out the year of 2017. They like to show that what they can do. Denmark use about half rate, and obviously now already have it out. And various other countries either have focused on it a lot or are not interested in it at all. USA at the time of my travel weren't looking at it. Now they are, which is interesting. They could in fact leapfrog us if they did it in the next 2 years. So my recommendation here would be is not to go cold turkey. Essentially, if we've got shelf life to use, I would hate to get to 2 years down the line, so 2024, and then be pulling it out altogether. I think we should be focusing on that sow what we can do with the sow and go half rate. There are many good papers out there utilising probiotics, prebiotics, enzymes, acid-based products to help reduce the need for zinc. But I'd be focused on that sow, and then I'd be looking at my diet with my nutritionist, making sure my crude protein's not too high, so those proteolytic bacteria don't get fed too well. And that's what I mean by amino acids. So if you look at the diet or amino acid, the digestible amino acids, as a proportion of crude protein, they should be really high. And that means that the protein that's there can be used 100%. It's not wasted to the bacteria. Diet suitability. So this is about understanding how old the piglet is, what the weight of that piglet is for the diet they're going to get fed. And that in that sort of weaning, first couple of weeks after weaning, is we're changing that diet quite a lot. And that can have a major effect. If we start to see improvements with the sow, or weaning a bigger piglet, potentially we then need to be changing those diets on quicker, or pulling the lowest sort of the baby's piglet one out, because we'll be feeding them too well. And that might sound counterintuitive, but actually we know that we can either hold back the gut or see poorer gut health if they're fed a too digestible, too high protein diet. And they need to be more fed higher fibers, more digestible or fermentable fibers. And the eubiotics is sort of a collective term for all those additives, essentially. Eubiotics just help us maintain that well-balanced and diverse microbiota. And we know that then has a massive effect on metabolic, which is sort of digestion, and immune homeostasis, so keeping them the same level. And then obviously that has a massive effect on animal health and performance. So there is a role to play by each of these. For me, probiotics are probably the least widely beneficial. And that's really because I think in gut health terms, we're still very naive. We don't necessarily know what we need to feed. But a prebiotic and postbiotics be sort of post-digestion. If we can mirror what would naturally be there in an animal's gut, that diversity, then generally, in my eyes, they're more stable, more robust. So I said I'd share with you a couple of the papers that I've worked on. One of them was looking at a sort of a eubiotic, a phytogenic, plant-based product, and if we could have an effect on gut health, and we did. But essentially, we also had an effect on piglet finish weight, or pig finish weight. At weaning, we had nothing. There was a very small amount, probably 100, 200 grams. By 10 weeks post-weaning, we had about 300 grams. But by finish, we had about 3.5 kilos. And this was only from a sow interaction. So the sows were fed oregano or essential oil. The piglets were all fed it. So really that's honing in on this effect of the sow and how far she can go in developing a piglet's gut health. And that's why my mantra is sort of start with sow. And in this trial, no zinc was fed because we were feeding them this alternative diet. Essentially, we wanted to produce all the feed at the same time to keep it the same. So we didn't include zinc in any diet. And that was sort of just an interesting side point. This farm was relatively good. They were producing about 30 piglets per sow per year. But they actually continued to use this product because they wanted to then look at tail biting and stopping the need for tail clipping. So an interesting concept. And if we look at the microbiome, so we looked at the bacteria that reside in the gut, and you do this by taking fecal samples and then running them for DNA. And you look back into sort of libraries and it tells you what bacteria you have. What we ended up seeing was if we, just use my cursor, and again, Ellen, stop me here if we want to chat more. But if we look sort of pre-farrowing, this is the sows of a control, so she didn't get any oregano, versus ones with oregano. You can see they haven't really had it for very long here. They've had it for a couple of days. There's no effect. As you'd imagine, it takes a couple of weeks to change the gut. But at weaning, the sows here had much less of the clostridials. So the clostridial group, as I've said, is potentially that front runner, but also can become problematic in sow mortality and other places with the piglets. So we had less of them, and we had more of the lactobacillus. So that's going to help piglets then be able to digest their diet, because they would be eating lactose products, milk products, but also that lactobacilli producing lactic acid, and then that helps then the gut functionality of those piglets. And if we look at the piglets, we've got essentially more different types, because sows are generally, they've got what works for them. And it takes longer for us to see change in sows because they're a bit more stable in the gut, less disruption. Piglets are quite easy to change. And actually in the 4 weeks previous to weaning, so we've got here the control at week 2. And incidentally, we wanted to take fecal samples at week 1, but they ate it all. And that's why I was saying piglets eat a lot of feces early on. They eat about 50 grams each, and they don't poop that much. So there was actually none left. So if you've got a piglet that's got poor gut health, everyone's going to get poor gut health. If they've got a really high salmonella count or E. coli count, it's going to spread throughout that litter really easily, or streptococcus and the like. So in weaning, week 4, just before weaning, we've got a massive difference here between the enterobacteria. So this group would include the E. coli, the salmonellas. And so potentially we're weaning a piglet that's got less risk of going wrong. So yeah, it was a really interesting look at microbiota. It was the first piece that I'd done in this area, and really it just drove the message home that sow is the biggest impact on the piglet. And looking at zinc replacement, actually Impario have done this for a number of years. The earliest work is in 2014, and here I'm starting with the sort of gut health side. So it's just fecal samples. We were looking at type pool samples to see if we could remove some of the salmonella. As I said, zinc doesn't do that, and you can see that here. We've got a control with the zinc included at the 3.1 kilos, the standard amount in that weaner feed. And here you've got an acid-based eubiotic, inhibit, and you can reduce some of that salmonella, and that's significant. And actually, you can increase the lactic acid bacteria as well. So there's ways in which we can control piglets. It still, for me, it can be a band-aid. So if we've not managed that sow and she's passing on really high levels of Clostridia and salmonellas and other things, then those piglets are going to be worse off, and we've got more to deal with at weaning. But if we're producing a nice piglet with a robust gut, potentially we don't need zinc. And this is daily weight gain, so it's relatively old, this trial now, but these are still good levels, about 450 grams per day between sort of day 1 and weaning, a little bit below weaning. And this is a high crude protein diet. I've left this on. These days we won't be using anything like 22 crude protein, but essentially you could still have potential value in removing that zinc. So you're not necessarily needing zinc, we're just using it as a crux. And then lastly, this is another trial. We challenged them with E. coli. This was done in Canada. And again, if we're challenging them with E. coli, we chose genetics that were susceptible to that, so not those ones that are resilient. And we did see that the zinc, zinc for me it's not going to show you a really good feed intake. We've got a low control here because they were challenged, and that's showing you that the E. coli is hitting them. So zinc is doing its job because it's E. coli challenge. But the acid-based products in the middle, the blue, the green and the orange, are giving you an improvement in performance because zinc's just not covering everything that was needed for them. So in one sense, what I'd like to see in the industry is that we focus on that sow, we give her the best ability to produce a healthy piglet, we feed for gut health, and we manage those pigs for reduced stress. And that would then give us a strong immune system And all the while we're thinking of that gut-brain microbiome axis, because that's really the key in the middle of it all. And that's it. Thanks for listening, and there's the links there for the report for Nuffield.
Great, thank you very much, Heidi. Brilliant presentation, and yeah, thoroughly enjoyed, and I think everybody's benefited yeah, from listening to you for that 3/4 of an hour. Therefore, thank you very much. We'll go on to Q&A, but briefly before going on to Q&A, I would just like to make you aware, as Mentor More Cymru has herd health plans available, 100% fully funded, up to £400. These eligibility criteria has changed in the last week. The points now is 50 points instead of 75, so more people can access this. So give me or Lauren a call to discuss further, and we'll send the form over to you. A few questions has come in, Heidi, if I can read them out, and then if you're happy to read them live.
Yeah.
So the first question, piglets eat a lot of feces. Is there a benefit to not removing feces if we think sow has good gut health?
Certainly. I mean, generally an indoor herd, we'd have slats. So most of that, once trodden on, would fall through, but there'd be a decent amount left around. If you've ever seen use of peat, then that was used as a bit of a bedding material, because it wasn't really a feed material, but it had really great benefits on gut health because it was a really good soil microbiome. Essentially, good, healthy sow feces can be seen like that. And a lot of other countries looking at immunity of the gilts will feed back various sow products, feces, sort of placentas, stuff from the birth of other piglets, because they want to pass on the immunity. And so it's a little bit like that, but it's not something we have to talk about widely. When we're using feedback in a management tool, some countries go hell for leather and create this sort of dried or liquid emulsion, which I don't necessarily think we need to do, and vets have various views on it, because you could be passing around problems in your herd. But certainly a sow to her piglets is totally natural, and they would do that in the wild or anywhere they could. So yeah, I'd be happy to leave it there if we knew that sow was healthy and good digestibility.
Okay, great, thank you very much. Another question that's come in, how could the average farmer access gut health?
So you can look at analysing feces. The salmonella and the lactic acid bacteria we did is a plating technique in that Newcastle work, and that can be done with universities. You can ask your vet, you can ask your nutritionist as well, what they might discuss. There's different ways of doing it. The DNA sequencing that I shared is very costly. It's about £10,000, and you get 96 wells, so there's not many wells, and that's really just used as a research tool. For me, what I'd be doing is, if I was looking for bad bacteria, I might use the plate technique, that salmonella. So we try and grow bacteria, and then we'd see what was there. And people do this for rotavirus and things like this. The other way to look at it, and that's something that's coming up, is you can also look for VFAs, volatile fatty acids. And so it would take a little bit of understanding with what's locally available to you, but you can measure for butyric acid, for instance, and that's produced within a healthy gut. That's why we feed it as an additive, because it's produced by a really healthy gut. So we sort of put it in there and try and make best use of that. But if you can measure that in the feces and see it going up, or we can start to sort of build an understanding of what's good, then that's quite a cheap way of looking at it. But generally, we always look at FCR, because that encompasses everything. and it encompasses all that inflammation. And I suppose in one sense, if you look at genetic targets, which is difficult when you've got closed herds or multiple crosses, but if you start to change something and then measure and see a value in SCR, benefit over the lifetime of the animal, you can generally say you've improved gut health, because it just wouldn't get there otherwise.
Great, thank you very much. Very useful information there. Another question that's come in. If you'd like to ask any more questions, we'll ask a few more and then we'll come to a close. A question that's come in here. My pigs are reared outdoors and I don't use antibiotics or any supplements. I like to keep to a natural diet as possible and encourage the piglets pre-weaning to start eating a pig mix as soon as they are ready, and also give them and the sow veg and fruit from a local source, wholesalers. Is this beneficial? Would it be beneficial to give oregano oil, and if so, at what amount?
Okay, yes, sounds great. I can imagine they love the fruit and veg. What I would say is, if you think you have any problems with looseness and anything that you think is a niggle, then potentially there is value there. But you don't sound like you need to jump on an additive, if everything works well. And if you've got zinc already removed, and that's fantastic. Oregano is it's an essential oil that's been around for many years. And in pigs, we see a multitude of different values. I've done work with it alongside vaccination programs, and we've seen improvements in vaccination titers, which we didn't expect. And that was in regards to ileitis. And I've also looked at it in the sow, and we've seen benefits in either piglet weaning weights if they were struggling, or feed efficiency of sows, and generally linked with heat stress. So in an outdoor herd, that might be interesting, heat stress. And in poultry, we've seen value on reducing worm burden. And so my next thoughts are, well, if we look at outdoor pigs, resistant worm burdens, that might be an interesting area to look at. But it's by no means a silver bullet, and it wouldn't necessarily help in all situations. But if you're interested, then just give me an email and we can chat more about it, or visit the website. The inclusions for Origstim in pigs is about 0.5 kilo to 1 kilo, depending on the challenge. And that's per tonne.
Great, thank you very much. I hope that helps you to answer that question. Thank you very much, Anne. Another question, how much oregano oil to sow?
In that trial, in that one where we did the microbiome work that I've shared, we did 0.5 kilo, and that was done as a top dress. So we innovated a new product essentially, so you didn't have to feed all sows all the time. You could give it as a top dress to sows that were potentially seeing an issue. It's interesting. You might think, oh, they won't want to eat that, but they're happy to eat a herby product on top of the feed. And yeah, we also provide it in liquid form, so that gives us a bit of flexibility as well. So it can go into the feed as a top dress or into the water. Great,
thank you very much. I think all questions have been answered now. Thank you very much, Heidi, for answering those live.
No, fine. The other, the gentleman, or the person that asked about the gut health on farm.
Yeah.
The one thing that we always do in a research scenario that we might not ever do really on farm is we do routine weekly scour scores, diarrhea scores, and that could be even constipation. So we're always looking for colour change, smell, and consistency, and I think that's probably a really good initial marker for piglets.
Oh, great! Yeah, top tip there. Yeah, thank you very much. I think we're finished like that now. All the questions have been answered. Thank you very much, Heidi, for a brilliant webinar. Thoroughly enjoyed. Thank you very much. Thank you all for joining tonight. We'd be grateful as a team if you could complete the evaluation form. I'll copy it in the chat now, and I'll send it around tomorrow too. But we'd be very grateful if you could spend a few minutes on completing that. Otherwise, that's all from me. Thank you very much again, Heidi, and thank you for joining as an audience.
Thank you.
Thank you very much.
Thanks,
Bye now.
bye-bye.